basic database concepts. Yeah. So last time we learned 3 advanced features for DBMS. Yeah. All right. So let's just learn some basic database concepts. Yeah. Define a database. What should we do when we need to define a database? What information do we need to provide? Yeah. All right. These things. First, we need to specify the structure. Okay? Structure. So basically, we need to define the structures of a list of tables. Yeah. We know the basic unit in a database is a table. Yeah. The structure. Structure, in the table, actually I gave you that animal DB example. So you can see the basic structure there. Yeah. Then data types. Yeah. For each field or each column, yeah. So here there are three terms, the same thing. Yeah. People just use, different places use the, different terms, but they are the same thing. Okay. Field, column, and attribute. Yeah, so here, another term, attribute. Yeah. So later I will explain. Yeah. So why people call different names, different terms in different places. Yeah. Data types. Yeah. So, and then another thing you need to provide in your table definitions, constraints of data. Yeah. Set some conditions, constraints. Yeah. So later we will, in our module 3, we will learn the details, how to define these things. Yeah. All right. So then we have a list of tables defined in a database. Then metadata, I talked about this concept last time. Yeah. That's basically descriptive data for data. Yeah. So this data, we refer to the business data. Okay. So our main data. Yeah. So the business data. Okay. Yeah. But the business data, when we store in the database, we need to find a way to organize the data. We need to tell DBMS how to organize, how to store, in which format, the detailed information. That descriptive part, metadata. Yeah. So the descriptive part, yeah, all these things, descriptive part, okay? The metadata. Yeah. But more. Remember last time I talked about stored procedure, right? Stored procedure also belongs to this metadata. So a lot of things. So when we use SQL commands or SQL statements to write some related information, that part belongs to metadata. Yeah. Refers to database definition. Yeah. Stored by DBMS in the form of a database catalog, concept, database catalog, yeah, or dictionary. Yeah. So that concept. Next slide, I will use a diagram to show you this database catalog. Yeah. How to store, maintain the metadata. So there is a special location inside on the hard drive of your database server. So that part, database catalog, right? Or dictionary. So, two separate parts. Yeah. Next slide, we will see the diagram. Two separate sections. One, the metadata part, another business data part. Yeah. All right. Yeah. So database system, the whole system, when we talk about, then two parts, the database part and the DBMS part together, so form a database system. Now this diagram, okay. Yeah, so look at stored database, this cylinder, yeah. So several, yeah. Stored database, many databases there. Then stored database definition, yeah, organized in a special structure. So the DBMS knows how to understand that information. Yeah. So we call the catalog. So this part, the catalog. Okay? Yeah. So then let's look at other parts. So other than these two parts. Yeah. So the whole picture, now we want to have an overview on the whole system. Yeah. We are users, programmers. Okay? Yeah. So we are here. Yeah. Yeah. So we play the role. So we are here. Yeah. All right. And so whole database system. Application. So now we need to develop. So we're doing this part. We write application programs. Yeah. And inside our program, application programs, Java, PHP, C#, you know, in certain high-level languages, then you need to do database queries inside. Inside your application programs, you need to embed your SQL statements in your application programs. Okay? There is a special programmer's interface. We use programmer's interface. Okay? So we follow the interface format, specific interface format. Yeah. So later I will compare two ways to do database programming in higher level language. One in Java. Java has its special way. Another in PHP. PHP uses a way completely different from the Java way. Yeah. So later I will get there, talk about how to do database programming in these two languages. All right. Then DBMS, this block. Okay? All right. Software to process queries programs. Yeah, so this block. Yeah. So DBM software, but process queries / programs, how to understand this block. Yeah. All right. So when we move from this block to this block, okay? Yeah. Our application programs, we, through the special interfaces, we need to send a SQL command. Yeah, the queries is embedded SQL commands. We send SQL commands to DBMS. Okay? Yeah. The DBMS, after it receives the SQL commands, there is one step it needs to do. Compilation. Compile the SQL statements. Okay? So that step is important. Compile the SQL statements. We know SQL statements just as normal commands, right? Yeah. Programming statements, we know we need to compile our program statements. Yeah. Here, SQL statements, you need to get them compiled inside DBMS. After compilation, you get a machine execution code, right? Yeah. Because the DBMS, in order to run the SQL commands, it needs to convert it to binary machine code inside machine, right? Yeah, inside the database server. Yeah. So through compilation, that step. Yeah. All right. So you have executable. After the compilation, you have executable machine code to run the SQL queries. Okay? Yeah. So that process. So then, after running those query commands, then to access, these two cylinders, both metadata part, definition, metadata part, and to access the business data, you have to because we cannot access the business data directly. Yeah. Because in that way, we may mess up. Okay? Yeah. So DBMS does not allow outside users to access the business data directly. Yeah. Both cylinders stored on hard drive, but we cannot access directly. So we have to go through, using this catalog, database catalog, metadata, to access the business data through the legal way. Okay, yeah, not arbitrary way. Yeah, yeah. So in that way, so that's how the all the database related operations. So you can see in this diagram. Okay, so you understand. Yeah. So then, later when we understand many different concepts, so you have this diagram in your mind, to help you understand better. Yeah. Because we need to understand a lot of things behind the scene. We cannot see it. Yeah, nobody can see it. But behind the scene, we need to have that picture. Yeah. Then we can understand a lot of concepts. Yeah. Otherwise, if you don't have this picture in your mind, so a lot of things hard to understand. Yeah. All right. Yeah. So next, then this part, application programs of databases. Yeah. This part I like to connect to the stored procedure, because last time I didn't expand. I mentioned that stored procedure and give you a little information, different programming languages we can access the same database server, communicate with same set of stored procedures. Yeah, last time I talked about that. Yeah. Here, let me give you more information related to that part. Yeah. Here we're talking about application programs of databases. Right. An application program accesses the database by sending queries to the DBMS. Yeah. In the previous diagram, so we have that picture, compilation, execution, right? Yeah. Yeah. So let's look at what we can do in an application program. In an application program, we can embed our SQL commands. Okay? Yes. So that point, let me explain that point. Yeah. In application programs, a little more information. Yeah, what do we do? Yeah. So how do we send SQL commands, right? So we embed SQL statements. Any SQL statements we can embed, double quotes, and SQL commands. Yeah. But when we do that, embed as parameters of certain in Java methods, right? Yeah, methods. Definitely of certain classes, but in PHP, functions. PHP functions. Yeah. Functions, methods, you pass SQL statements as parameters, input parameters. Okay? Yeah. So that method, that function, inside that method function, so then the certain interfaces used to do the communication. Yeah. So inside your high-level language, so here, let me draw another part. Okay, so here, Java or PHP, high-level language. Okay, yeah, the high-level language here, DBMS. Okay, yeah, DBMS. Then, how to do communication? Yeah, through interfaces. Interfaces we call programmers interface. Programming interfaces. Interfaces. Okay, yeah, the communication. Yeah. So more details, how to use those interfaces. Yeah. So I leave that part, that details in later section, later topics. Yeah. All right. Yeah, because still a lot of details. Okay, a lot of details. So here I just give you a high level picture. Yeah. All right. Yeah. So then, now we can get into this part, embedded SQL command, this part. Yeah. Any SQL statement we can run, okay? Yeah. Yeah. Double quotes. Yeah. Any valid SQL statement we can call to run in the remote DBMS server. Then, we just call create database name, right? Yeah. So the statement create database name. Yeah. That's the SQL statement. So you can create a database. Yeah. All right. Then several other things we can do. Oh, here. All right. Create a table. Yeah. Define a table. Yeah. Inside the double quotes, you'll write that create table statement. Okay? Yeah. In a string, yeah, string format, yeah. So you pass, you send it, so you create that table. When you run it, you create that table. Create a stored procedure. Yeah. Stored procedure, the definition of the whole function is formed by a sequence of SQL statements, right? So you send statement by statement. Okay? Yeah. Stored procedure. You can create it in your programming languages. All right? Yeah. Then, after you create, you can call a store procedure. Okay? Yeah. Call, just like call function. Okay? Double quotes, call procedure name. Okay? Call your procedure name. Okay? You call it. Then, in the database server inside the DBMS, this store procedure is executed. After it is executed, it does certain data processing. Some data processing, some output return, but some data processing, no output return, just like a void function. Okay, void function, no output. Yeah. Two types of stored procedures. First type with output generated. So you can receive the return output. Second type, no output. Okay? Two types of stored procedures. Do other regular queries. Yeah. See? Yeah. So you can do. Yeah. in your high-level languages, you can do a lot of things, okay, in this way. Yeah. All right. Yeah. But, so definitely, so because when you do these things, you change your database. Actually, you change the database. Yeah. And I mentioned, when you change the database, because it's a high-level business decision. Yeah. So here, you have the capability to make the change, but if you are allowed to change, that's a business decision, right? Yeah. Otherwise, you may mess up the, original database. Yeah. You change, without permissions, you make some, damage, right? You may cause some damage. Yeah. Yeah. Things like that. Yeah. All right. Yeah. So we complete this slide. And this part A topic, we complete the part A. Yeah. All right. Next, I want to go to part B, another important topic in part B, related to the database design. Yeah. All right. Yeah. Part B. Yeah. Yeah. B.1 first. The topic here, data normalization, another important topic in database design. Yeah, we need to understand this concept, database, data normalization idea. First, B.1, redundancy problem. Yeah. Redundancy. All right. So what's the redundancy problem? Store the same data multiple times. Redundancy. Yeah. So in database design, it is very common. You may have redundancy in your data. Yeah. Even if you try very hard, you may have the redundancy. So now let's study this redundancy problem in database design. Yeah. Is it a good thing or bad thing? Yeah. There is, advantages and disadvantages for the redundancy issue. Okay? All right. First, the drawbacks. Yeah. So negative. Yeah. We want to avoid duplication of effort. Yeah. The same piece of data you need to, write multiple times, right? Table 1, you store one copy. Table 2, you store the same copy another time. That's possible, right? Yeah. So why people do that? Yeah, later I can explain. Yeah. So why? Even if, because sometimes people may not realize the redundancy, but most of the time, people know that redundancy, but still they are willing to store the data with the redundancy. Yeah. So that question. Yeah. If you store multiple copies in your database, then when you update, think about, you need to perform updates multiple times. Yeah. So that's the duplication of effort. Yeah. If you miss any update, because if you, for example, if you have 3 copies, the same piece of data, you store 3 different copies, okay? 3 different tables. But after you modify that piece of data, you only update 2 of the 3. Then your business data, you have the inconsistency problem, right? Yeah, inconsistent. Yeah. So that problem, definitely you don't want that happen. Yeah. All right. So that's the, something you want to avoid. Another drawback, wasting storage space. Yeah. Yeah. So this problem, we know storage space is relatively cheap. Yeah. So this we do not treat as a big problem. Yeah. So it exists, but we use a little more storage space. But if the redundancy is unnecessary, later I will talk about, some redundancy is necessary. We need it. Okay? We need certain redundancy. Some redundancy is useful. Yeah. So we don't want to remove useful redundancy. But some redundancy is not useful. Okay? So we want to remove. So we remove those unnecessary redundancy. We can save some storage space. Yeah. All right. Yeah. So then that inconsistent data. Yeah. Yeah. So if you do not manage your data carefully, keep track of your data closely, maintain the consistency closely, you may have the inconsistent data problem in your business data. Yeah. So that happens. This problem happens frequently in the real world application. Yeah. So I saw those things. Yeah. So because the business applications developed by the programmers, they have to write their code carefully to stop all the inconsistency problem, right? Yeah, but it's very common, so they miss a few little things. Yeah, then suddenly the data is inconsistent. The same copy in different tables have different values. Yeah, so that problem. All right. Files that represent the same data may become inconsistent. Yeah. The meaning, but here I like to explain this. So, word files. Yeah. Although everyone here, you know the meaning of file, but here the meaning of file is slightly different than our usual understanding of file. Yeah. So it's a file, physical file, we know, stored on the hard drive, physical file. But the file here in our database context, the file here refers to special meaning. Tables. Yeah. So one file corresponds to one table. Okay? So in this sentence, actually, we can replace this file by tables. Yeah. Why? Why is that? Yeah. The reason, because we know each table, one table is a storage unit in your databases. Yeah. Our database, since when we define a database, we define a sequence of tables. Yeah. And when you store the data in those tables, how to store the data internally inside a hard drive of those tables. Okay? Yeah. So the storage format, one table is stored as one file. Okay? One physical file. Yeah. 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 So that's why sometimes when you see in our database context, when people write files, so you connect to tables immediately. Yeah. Refer to tables. Yeah. Yeah. Other places, other different contexts, you cannot. You cannot replace files by tables. Yeah. but in our database context, we can do that. Yeah. Later in Module 5, I need to explain in what format each table, each file, each table is stored on the hard drive. Yeah. Module 5, I will give you that information because our algorithm, our search algorithm needs to use the special structure of table storage format. Our algorithm needs to use that structure. Okay? So we need to understand the underlying storage format for each table. Okay? Yeah. Record by record. Okay? Row by row on a hard drive. Yeah. All right. That's the Module 5 topic. Yeah. All right. Yeah. So here, so you know, yeah, that. Store physically as a file on a hard disk. Yeah. All right. But next, yeah. D.2, concept of data normalization. Yeah. Now we want to, you know, because the drawbacks in the B.1, so it looks like all those things not good, so we want to remove redundancy first. Yeah. So that step we call the data normalization. Remove the redundancy. Okay? Normalize the data. Yeah. That's the process to remove those redundancy. Okay. All right. Data normalization, ideal situation. Yeah. Let's look at the ideal situation. Yeah. How to achieve ideal situation? We know how to achieve ideal. How to get ideal case. Yeah. All right. Store each logical data item in exactly one place in the table. No redundancy. That means no redundancy. Yeah. No duplicate copies. Okay. Only single copy. Then when you update the data, you only need to update it in one place. Very easy. And there is no data inconsistency problem, right? Yeah. No data inconsistency problem. Yeah. All right. Logical data item. Yeah. A data item appears in multiple tables with different field names for convenience. Yeah, so here. Yeah. Here, I explain. So why people store one data item in multiple tables with different field names. Yeah. So here, the reason is for convenience. Okay. Yeah. For convenience. Yeah. Okay. So when you use the data, so you like the convenience, right? Yeah. People like easy way. Yeah. Yeah. Faster way to access that part of the data. Okay. Yeah. For convenience. So there is some reason to use multiple copies of one logical data item. Yeah. Okay? Yeah. Although there are several drawbacks, but sometimes people still like to use that redundant way. Yeah. Convenience is one benefit, and there are several other reasons. Yeah. Benefits. Yeah. Talk about. Yeah. So here, the benefits. Okay. First, the benefits, because this is under the data normalization title, so we want to look at the benefits of data normalization. Okay. Yeah. Not the opposite way. Opposite way, because data normalization means we remove all the redundancy. That's normalization. But there is the opposite way, denormalization. Denormalization, we do not remove redundancy. We keep certain redundancy. So that's the denormalization. Okay? So we will look at these two questions. Yeah. The benefits here, normalization, save storage space, yeah. Right. Easier updates. Yeah. Only one copy. Yeah. Update one copy. And you don't worry about the inconsistency, data inconsistency problem. Yeah. And ensure data consistency. Yeah. That's very easy. Yeah. Yeah. Data normalization. Yeah. Right. The question, should we always make our data normalized? Yes. After that, yeah. So if you do not have some overall understanding, okay, global view, with some global view of the whole picture, so you may feel, oh, we like to have data normalization, yeah, yeah. But actually, the answer is not simple. Yeah. The answer to this question, okay, should we always make our data normalized? Yeah. Sometimes we don't want to make our data normalized. If we have some special objectives, yeah, so we want to achieve some special objectives, so we want to do denormalization. Okay, yeah. So we need to talk about that situation. Yeah. All right. So then another concept called controlled redundancy. Yeah. So we can have some redundancy, but we need to control the redundancy. Okay? Yeah. Put all the redundancy under control. Okay? Yeah. If some redundancy you cannot control, that means when you update, but you do not control small part of the redundancy, that data inconsistency problem occurs. No? Because you forget to update a few copies. Yeah. So here we need to make sure all the redundancy must be under control. Yeah. All right. Why sometimes redundancy is not a bad thing? Yeah. So this topic actually quite important. Yeah. So here I will, expand. Yeah. Because in our business applications, we can do a lot of things under this question. Yeah. Remember last time I talked about Google search engine, right? Actually, Google search engine, that application is an excellent example under this question. Okay? So something really big, okay? Google search engine, we can understand under this question. Okay. All right. Performance consideration on relatively complex query. Let me explain this sentence. Yeah. So the biggest benefit, sometimes we need to use redundancy. Yeah. Redundant data can help us get a better performance. How? Yeah, so that's a big story. I need to expand. Okay? Yeah. So here, just give you the result. Yeah. The result is because when we allow redundancy, we need to pay a little more, right? Yeah. Because we need to do a lot of things to make things right. We need to pay a lot of effort to make the redundancy under control, right? A lot of work. That's our responsibilities. But with that extra amount of work, we need to have benefits. We need to have some big benefits to justify it, right? Otherwise, you do a lot of work, but no benefit. Why you do it? Yeah. So here, what's the biggest benefit here? Performance gain. Yeah. The Google search engine, the performance of Google search is very fast. Okay. When you type keywords, you get a search result quickly. That's the benefit. Performance benefit. Okay? Yeah. So relative. So here, still, yeah, because that story about Google search engine, I will talk about later. Later, I will, give you the whole story. Yeah. Here, this sentence, we do not talk about Google search engine. Okay, so here in this sentence, we talk about relatively complex query. SQL query, some SQL query is very simple, but some SQL query could be very complicated, extremely complicated, long. Yeah. So complicated. Yeah. Think about. So here, I'll give you one example that we use, that sometimes in our business applications, we may need to use some very complex queries. Yeah. Why those queries are so complicated? Because people need to do some difficult data processing work. Yeah, so you need to do data processing. A lot of sophisticated data processing work. That's not easy. You need to access many tables and a lot of manipulations. Finally, you get the desired data. So here, we're talking about those complex SQL queries. Yeah. That could be slow, right? Yeah, because you need to access many tables, do a lot of manipulations. You need a lot of time. Think about that. Then the response time will be relatively slow, right? When you run those complex queries directly, then the response time will be slow. That's natural, right? Yeah, because you do a lot of work. So then a lot of time in slow responses. Okay? Yeah? But if your customers, if you require your customers wait several seconds, that's not good experience, right? Yeah, for your customers. For certain tasks, related to complex SQL queries, the waiting time relatively long, let's say multiple seconds. Think about that. And not, in minutes, hours. So we don't go that far, okay? Yeah, like 5 seconds. 5 seconds from your customer's perspective, is that too long? After they click the button, they need to wait 5 seconds. So then, most of the time, they will hate it, right? Yeah. So nobody likes that long. 5 seconds, too long. Okay? All right, now we want to solve this problem. We don't want this to happen, okay? So in your business operations, we don't want this to happen in our web applications. So how do we avoid it? Here, we can use the redundant data to avoid it. Redundant data, now we can avoid it. Yeah. How do you use redundant? Because this complex query running relatively slow, can we run it once and store the result or results in some tables? How about that? Store the results of complex queries in other new tables. How about that? When we do that, do you think it's redundant? Yeah, because it's not original data, right? So we treat as derived data. So this part we treat as, so they're derived data. not original data, okay? Derived data, okay? Redundant data, right? Yeah. Derived data, it means you can remove this data from your database, okay? After you remove, because next time when you need to use it, you can run the same complex queries. You can generate the same data another time, right? Yeah. So you can recover easily. You just, use a little more time to run the same set of complex queries. You can get them. Yeah. But here, yeah, so people store them in new tables. When your customers need to use these complex queries, they don't need to run that complex queries again. They just access those special tables, right? Yeah. Retrieve data from existing tables extremely fast. Okay. See? So we solve that performance bottleneck. Okay? Yeah, in this way, we solve the performance bottleneck. Okay? We avoid that 5-second delay. Think about it. Yeah, that's the benefit. Okay? Performance gain. Yeah. All right. Yeah. So here you can see, yeah, redundancy here, it's a good thing. Yeah. Yeah, derived data comes from multiple tables. Yeah. All right. The queries to generate the data rather time consuming. Yeah. Yeah. Okay. So anytime if we want to recover this part of the data, we just run those complex queries. Yeah. All right. Yeah. Even need some complex algorithm, yeah, for data processing. Yeah. So here you just know that meaning. Yeah. Right. Yeah. Faster access if we store it in a new table. Yeah. So, all right. So here I use a diagram, yeah, to explain this idea. Okay. Yeah. Yeah. So this block now we replace by derived data. Yes. A single table, we store the result. Yeah. All right. So there. Every time when our users need to call these complex queries, we just return the result of this table very fast. Yeah. So that idea. Yeah. All right. Yeah. So this idea very simple, right? Yeah. Very simple. Yeah. But this idea, yeah, we can understand it as the basic idea of the Google search engine already. Yeah. Google search engine, yeah. Because if you work on, so not necessarily complex query, some time-consuming data processing work. Yeah. So this block in the Google search engine, so a sequence of complex data processing operations. Yeah, not necessarily queries, okay? Yeah, operations. Then, time-consuming, after that processing, we store the result in another table, derived table data. Then, when people type keywords-based search, they just use this derived data to return a fast search result. Yeah. Not going through, complex data processing. Okay, and that's the basic idea of the Google search engine. You can see from this diagram. Yeah. Oh, sorry. Yeah. Yeah. So this process we call the denormalization. Yeah. So we intentionally add redundancy in our data, right? Yeah. We don't remove redundancy. We add redundancy in our business data. Yeah. Yeah. Denormalization. See? Yeah. Yeah. useful, yeah? So the benefit, yeah, important, the big benefit here, yeah. All right. Yeah. All right, next, I'll talk about data denormalization topic. Yeah. All right, let me see. Oh, yeah, I have 18 minutes. Yeah. Yeah. Let me see. Yeah. So this data denormalization. Yeah. Yeah. Here I like to give you some case studies. Yeah. The important data denormalization, but here I only have 18 minutes left. Yeah. So let me see if I definitely not enough to give you case studies. Yeah. Let me see my next topic. Yeah. Yeah. So all right. The goal. Yeah. So when I get to that story, so I may need to use another class to do the case study. Yeah. I want to give you 2 case studies. Yeah. All right. So the goal of data denormalization, we simplify the computation. Yeah. Yeah. Some business computation, very complicated, time consuming. Yeah. And for our business purpose, we have to go through those complex operations. Yeah. You cannot bypass it. Yeah. You have to do those time consuming operations. Yeah. All right. But we want to find a way to simplify the computation. Yeah. When our users access the data, we want our users bypass the complex computation, time-consuming, complex computation process. Yeah. So they can access the result of the computation immediately. That's the idea. Yeah. View. Yeah. All right. So it's a space performance trade-off. So here, how do we get a fast performance gain? Because we use more space to store derived data. So we sacrifice in the space factor, storage space factor. We pay more. Yeah. We use more space, storage space to store the derived data. Okay? Yeah. So that's our cost. Yeah. We're willing to pay that cost. Yeah. Then the gain is we get significant performance gain. Yeah. Yeah. So that's our view of this way, denormalization. Yeah. Why we can get so much faster search result. Yeah. Because behind the scene, we do a lot of time-consuming data processing work. Yeah. People cannot see it. Yeah. Yeah. But we already pay a lot of cost there. Yeah. All right. Use more space to exchange for better performance. Yeah. All right. With more effort for data consistency. Yeah, because here you need to, when you do things like this, you need to keep an eye closely on your business data, make sure you have the data consistency maintained in your databases. Yeah. Because think about when you generate large amount of derived data, then in your original tables, if you update certain portion of your original tables, then you have to update your derived data, right? Yeah? Otherwise, you have inconsistent data. Yeah. So you have the responsibility to ensure your data consistency. Yeah. So that's very important. Yeah. 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 That may not be easy. Yeah. That may not be easy. Yeah. Yeah. But for this part, so we like to write some special programs. Okay. Every time we modify the data, because we want to make sure, all the related data items must be updated. All right. A useful idea in application. Yes. Here, now, I need to talk about case studies. Because application. In application, I give you 2 case studies in applications. The first one is the Google search engine. The second one is one project I did many years ago. The idea, so idea is very interesting. So here, mainly I want to describe why we can get a much better performance because we use some special algorithms. But those case studies, definitely I couldn't do today. All right, so I plan to do case studies. Okay, the first one, Google search engine. Main idea of the Google search engine. Okay. The second one, is a classroom project I did 10-something years ago. Okay. Related to data processing. All right, so let me, so these 2 case studies, we use a special method called the pre-processing approach. So mainly I want to explain this pre-processing idea. What's the meaning of pre-processing? From the word, so you can guess. So here I want to describe the meaning of this one. Pre-processing means before the user, our users send their requests. Before, right? Before the request time. So this pre means before. You do your data processing. Before the request time. At the request time, already too late, right? So you want to do your data processing ahead of the time. Okay? Do preparation. Okay? All right? So lot of preparation work, time-consuming preparation work. Okay, There, you generate very important derived data. Okay, Then, when your users send their requests, search engine requests. Okay, Then in that class project, we also do the search. So this project also related to another Google application. Okay, So this class project, because in our class, we can only do simulation, right? We can only do simulation. Okay, so this project I define as a simulation of another Google application, Google Maps application. Google Maps. Okay? Very important application, right? But Google Maps, when you search your locations, using Google Maps tool, your mouse you can drag, right? Location, drag. When you move your mouse cursor, then different map data is loaded, right? Yeah. When the map data loaded, okay, based on your actions on the Google Map. Yeah. The response time very fast. Okay. When you move your mouse cursor, immediately the new map data is loaded. Okay. Yeah. So the question is, so here in our class we can only do simulation. Okay. Yeah. So, it's a small project, small class project, but we do simulation. Google Maps. Okay. Yeah. All right. So how much time? Let me look at. Yeah, 8-something minutes. Yeah. Here, let me describe this. Yeah. I can use 8 minutes to describe this Google Map simulation. Yeah. Yeah. How to simulate? So how do we simulate map data? Because it's hard to access the real map data, right? Yeah. Very large amount of data, the database. So our students, we cannot access real map data. So here, then I find a simple way to do the simulation. Yeah. All right. First, I need to simulate Earth. Yeah, map on the Earth, right? So first I need to simulate the Earth. Yeah. The whole Earth, I use a big rectangle to simulate the Earth. Okay? Yeah. Yeah. The whole region inside this rectangle, represents whole Earth. Yeah. All right. Then, local area, right? Because the map data stored based on the local regions, many local regions. Yeah. How do we represent local region? Yeah. How do we simulate local region, the data of local region? Simple way. Yeah. Yeah. So here, the local region, I use zip code. Yeah. Okay. Let's say each zip code represents one local region. How about that? Okay. Yeah. In different countries, here we just simplify it. Yeah. Let's assume all local regions can be represented using their corresponding zip code. Okay? Yeah. Simplification. Yeah. All right. Then, how do I simulate what map data of one local region? One local region, one zip code. One zip code. How do you use a simple way to represent it? Okay? Yeah. Here, I use a simple way. One triangle represents one local region. How about that? Okay? So everything inside each triangle corresponds to one zip code. One zip code. Okay? Yeah. All right. Now I need to simulate large number of local regions. The map data. Map data. So what's the map data? The 3 coordinates of one triangle, that's the map data. That's the simulation of local region map data. Yeah. 3 coordinates of one triangle. Yeah. Simple way. Yeah. Okay? All right. Map data. Yeah. One triangle, right? Yeah. Then I generate 1 million triangles. Yeah. So I use MATLAB functions to generate. So in MATLAB, there is a special function to do triangulation. Triangulation function. Triangulation on this rectangle, on this rectangle, okay? So I run that function to generate 1 million triangles. How about that? Okay? Yeah. The generated triangle is a triangle partition. Okay, partition this rectangle in 1 million triangles. Yeah. Then I store 1 million triangle data in a text file. There is a special format, text file. Okay, yeah. That text file, that's our data file, our map data, simulated map data. I store. I upload that map data. So our students download that map data. Okay? So you do your work. Here, let me give you the problem. Yeah. Because I only have 3-something minutes. I can only give you the simulation problem. Okay? Simulation problem. All right. How to simulate map loading operation using this simple setup. Very simple setup. Okay? All right. Yeah. Yeah. When we do the map loading, we need to give one location, one specific location on Earth, right? Yeah, one specific location on Earth. Yeah. Here, I use the simulation. How do I pass? The input is one location on Earth. Okay? This one location, we can use XY coordinates. How about that? Okay? XY coordinate. Yeah. 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 So when we pass XY coordinate, then the location is given. Then which triangle contains this location? We need to find it. Okay? In that 1 million triangles, which one contains this point? That's the problem. That's the simulation problem. Okay? You need to do the map search. Which triangle contains this point? Yeah. You need to find the faster way to find the right triangle containing this point, this location. Yeah. After you find triangles, you give me the 3 coordinates of this triangle. Yeah. So then I treat it as you find the region and you load that map data. Yeah. You load. When you tell me that specific triangle containing this location, I treat it as you load the map data of that region. How about that? That's simulation. Okay? That's the problem, the project. Okay? Yeah. All right. Yeah, here. Yeah. Last one. Then you can think about, if you do not use some special algorithm, if you just do the search in 1 million triangle, do you want to go through 1 million triangle to see? For each triangle, you can apply some math formula. Yeah, so I provide my students how to detect, given a triangle, 3 coordinates of 3 vertices, give the coordinates of 3 vertices of a triangle, how to detect if the given point is inside the triangle. I give them formula. Okay? You just plug in my formula, look at the positive or negative. Okay? If it's positive, then the point is inside the triangle. If it's negative, then the point is outside triangle. Okay? If it's 0 on the boundary, the point is on the edges, boundary of the triangle. Yeah? Simple. You plug in. Yeah, simple formula. Okay? I give my students that formula. Okay? Then, if you do not do any special treatment, you do a for loop. Okay? You have 1 million triangles. You run the for loop from the first triangle through the last triangle. Each one you need to plug in. Okay? Then you plug in the formula 1 million times, right? 1 million times. Okay? Yeah? Sooner or later, you can find the right one, right triangle that contains positive, only one. Okay? Only one contains this point, this location. Yeah. Yeah. Then the response time, very slow. Okay? Yeah. The response time, if you do in that way, yeah, like something like 2 or 3 minutes. Okay? 2 or 3 minutes. Yeah. That's slow. Okay? Yeah. Yeah. But Later, next time, I'll give you my idea. We improve it less than 1 second. If you do it the right way, you can use a fraction of a second. You can find the right triangle that fast. See? How much is the improvement? Okay? All right. Oh, question?
It only gives us the rough location, though, like not the precise location. Just the rough location.
Yeah, rough location. Yeah. Yeah, rough location. Yeah. Yeah. Not precise because we do simulation, right? Yeah. So we do not try to, make it very restrict. Okay. Yeah. Just get an idea. Yeah. All right. Yeah. Next time I may give you 2 case studies. Yeah. The stories of these 2 case studies.